All right, so we're looking at part 2 of today's notes. And part 2, even though we're still talking about triangles, we're still talking about determining the measures of angles in a triangle. Now we're looking at the exterior angle theorem. This theorem states that measures of an exterior angle is equal to the sum, that the measure of an exterior angle is equal to the sum of its remote interior angles. We already mentioned that interior means the inside. My goodness, let me see if I can spell that correctly. The inside angles. When we're talking about exterior angles, we are talking about the outside angles. And when we're looking at the word remote here, for like the remote interior angles, that means the two that are off by themselves. You know, remote, like if you're on a remote island, you're off by yourself. So off by themselves. And we'll look at exactly where those are located here in just a moment. So our exterior angle states that this outside angle right here, and that's the exterior angle, the angle outside of a triangle. Notice that this angle is made by running that straight line past the end of that triangle. Here's the inside angle from the triangle, and we formed a separate angle by making that line. That is your outside exterior angle right here. And this outside exterior angle is equal to the two remote interior angles added up together. That's saying if angle 1 plus angle 2 were added together, that would equal angle 4 here. That's what that's saying. These two angles added up is going to equal this one. That makes sense because a straight line equals 180 degrees. The inside angles of a triangle equal 180 degrees. So if all three of these equal 180, and this straight line equals 180, well, in order for these two to equal 180, I'd have to take 180 minus this angle to get this number. Well, 180 minus this number is going to give me the sum of these two numbers here. So we're really going to take a look at it here in just a moment when we can look at our example here. All right, so we have another example with those equations. Okay, we're still working with building those equations. We're just using the other type of theorem where it says that these two remote angles, angle A and angle B, are equal to this exterior angle right here. Okay, so we can set up, solve for x, and figure out what all of these angles equal. Now we could really easily figure out what this angle equals right here, because well, that's not x. I shouldn't use x because we're solving for something else x. So let's just use A as our angle here. We can easily figure out what this angle is because we have a straight line. And if I take 180 degrees, because that's what makes a straight line, minus the angle measurement we know, 83, that's going to give us this missing angle measurement right here. So we end up with 7, 0, 17, 17 minus 5, what is that? 16, 15, 14, 15, 11, 9, 9. I should have known that. Sorry, my brain, it's early and my brain's not working great. 97. So this angle measures 97 degrees. Now we easily find that one, but we can't really tell just from that what these two separate angle measurements are. We can tell that they're equal to 83, but we don't know exactly what those two are, which is why we have to solve for x here and then be able to tell individually what these remote angles are. So since the exterior angle theorem says that this angle here and this angle here are equal to this exterior angle, we can set them equal to that exterior angle and figure out what x is. So that means we're going to set it at 9x plus 4, that's this angle here, plus 4x plus 1, this angle here should be equal to 83 degrees, that exterior angle. Now we just have our solving equation steps. No d to distribute, but we do have combining like terms. We have two x terms that need to go together. And we also have two constants that need to go together. 9x plus 4x is 13x. 4 plus 1 is 5. And those equal 83. We do not have to move a variable because we already have the variable on one side by itself, but we do have to add or subtract this constant. We have to subtract because we initially had an addition there. That's a zero pair. We get 13x equals 83 minus 5, which is going to be 78, I believe. Yep. It's 83 minus 3, that's 80. Minus 2 more is 78. Yep. So then we have to divide by 13 here. 13 divided by 13 is just the 1x. And then we have 78 divided by 13. Let's see here. Hold on the calculator. 78 divided by 13 is 6. So our x is equal to 6. And just like we did in the first video, now we have to take this 6 and we have to plug it back in to where the x is in both of those expressions to figure out what the angle measurement are. So I'm going to switch my colors here. I'm going to take my 9x plus 4, but instead of times x, I'm going to plug in that 6. 9 times 6 plus 4. 9 times 6 is 54. 54 plus 4 is 58, so that means this angle measures 58 degrees. And then for this one down here, 4 times, instead of my x, plug in that 6, 4 times 6 plus 1. 4 times 6 is 24, plus 1 is 25. So we can check to make sure that our angles are correct. We already figured out this was supposed to be 97. So two ways. We could either add up these three numbers to make sure they equal 180, or we can just add up those two numbers to make sure they equal 83 because that's what they're supposed to be equal to anyway. So I'm going to take 58 plus 25, which equals, let's see, that's 13. And that is 83. So these two angles added together equals that exterior angle, which is exactly what our exterior angle theorem says is supposed to happen. All right, so that was the exterior angle theorem. And let's take a little bit more look at the vocabulary here, just so we know what we're talking about. Our vocabulary, let me stick to my pencil here. Okay, interior angles are the inside angles of a shape, and here we're talking about the inside angles of our triangle. So we're talking about the inside angles of our triangles. Those are always going to be interior angles. When we're talking about exterior angles, we're talking about an outside angle made by drawing a line past an existing interior angle. So again, what would that look like if we had a triangle here? If I drew this line past that existing angle right there, then I'm making that exterior angle on the outside. Okay, that's your exterior angle. Remote interior angles are the angles off by themselves. Opposite from the exterior angle. So again, if I have that same example of a triangle here and I draw that line, there's my exterior angle. My remote triangles are going to be these two, I'm sorry, my remote angles, interior angles are going to be the two angles on this side, opposite where that exterior angle is located. And then we're talking about a linear pair or a straight angle. Our linear pair or straight angle is going to be the interior and the exterior angle that make that straight line. So let's write that down. The interior and exterior angle of a triangle that make a straight line. All right, so if I'm looking at an example, again, let's look at that same example. We had a triangle, we make that exterior angle, this angle here, and this angle here, they make up a straight line. That's the interior and exterior of a triangle that make a straight line. Those would be considered a linear pair of angles. Any two angles that are making that straight line right there. All right, make sure you have everything down on your notes and go ahead and submit that to me before we look at your guided practice. Okay? Thanks, guys.